Hello students, welcome to Legacy IAS Academy. In today's video, we are going to discuss about the recent launch which has successfully been completed by Indian Space Research Organization ISRO, that is the launch of INSAT-3DS satellites. The satellite has been launched using the satellite launch vehicle that is called as GSLV, that is Geosynchronous Satellite Launch Vehicle. Now this particular launch vehicle, which has been used to make sure that INSAT-3DS enter into its orbit, is also referred as naughty boy. Now, what is the reason behind this terminology? And overall brief about these launch vehicles is what we are going to discuss in this particular video. So, first of all, to give you the brief context of the topic, the ISRO has recently launched a new generation meteorological satellite. Meteorological satellite means the satellite which helps in understanding the weather patterns, also forecast the weather, help in forecasting weather, and thus overall give the IMD possibility to make people aware about the changing weather situations, the weather phenomena, and thus make people more, what you can say, understanding about the developing and evolving weather. So INSAT-3DS basically is meant to carry out enhanced monitoring of Earth's surface, atmosphere, oceans, and environment. Now INSAT-3DS will augment the capabilities of already the previous such kind of series of satellites that is already orbiting around the orbit, that is INSAT-3D and INSAT-3DR. So this is third in the series of the similar satellites. It will boost India's weather and climate prediction services, early warnings, as well as disaster management services, because you know that India is one of the most disaster prone country of the world, because it has a huge coastline that makes it vulnerable to weather phenomena such as cyclones, coastal floodings, tornadoes, and all these kind of things. Apart from that, since India lies in tropical zone, you have a lot of weather phenomena that is associated with intense heating of the ground surface, such as thunderstorms, lightning, and all these kind of things. So obviously such kind of satellites will help us in having a proper strategy against the management of certain disaster linked with such kind of weather phenomena. Now INSAT-3DS satellite rode on GSLV F-14 rocket to reach its intended geostationary orbit. What is geostationary orbit? We'll discuss that in a while. Now GSLV is one of the three main rockets that is being used by ISRO currently. One of the major rocket that it uses is PSLV, that is Polar Satellite Launch Vehicle. And other is called as LVM. LVM earlier was also called as GSLV Mk3. Now GSLV has had a rather patchy track record as far as its success is concerned, because it is because of this region, because of the many failures it has witnessed during its flight records, it is referred generally as a naughty boy. Now, however, this time it was it made a very flawless kind of flight and deposited the satellite in the desired orbit. Now we have discussed slightly before that what is the geostationary orbit. So basically orbit can be classified in two types. One is the polar orbits, other is the geostationary orbit. This is on the basis of the distance from the Earth around which the satellite is orbiting the Earth. So geostationary orbit is basically situated somewhere about 36,000 kilometers away from the surface of the Earth, and this is where the INSAT satellite has been deposited. Now, why it is called as the naughty boy? So obviously GSLV had flown 15 times before this, and out of these 15 times, 4 of these had been unsuccessful, which is a very high failure rate for any rocket. Now PSLV, on the other hand, if you try to understand the comparison, as we discussed GSLV, PSLV, LVM3 kind of rocket that is being used here, LVM3. So PSLV, the rocket that ISRO has used the maximum number of times, has failed only twice in over 60 launches, and compared to that, GSLV has failed 4 times out of just 15 launches. So success rate of GSLV is very low, including the first time it was tried way back in 1993. And also if you talk about the LVM3 rocket, which was the rocket used for launching Chandrayaan-3, so it has flown 7 times and never failed. The uncertainties over its performance had not dissipated completely, and that is the reason why Saturday's launch, when ISRO was conducting, people, rather than focusing upon the satellite, they were largely focused on whether the GSLV will become successful or not. Now, if we try to briefly understand the comparison between PSLV and GSLV, that is what we given here. So first of all, if you look at the vehicle specification, the height itself, both are almost having similar height. However, GSLV is slightly longer. PSLV is 44 meter, while GSLV stands at 49.13 meter. If you talk about the number of stages means separation stages and the fuel burning stages. So PSLV has 4 stages, while GSLV has only 3 stages. In terms of lift-off mass, PSLV has 320 tons of lift-off mass, while GSLV has 414.75 tons. Obviously, PSLV is the old horse of the workhorse of the ISRO. It was launched first time in September 28, 1993. On the other hand, GSLV was launched on April 18, 2001 for the first time. And last, if you talk about the payload capacity, PSLV can take up to 1750 kilograms of payloads to Sun synchronous polar orbit, also called as polar transfer orbit, which is situated at 600 km altitude from the Earth's surface. On the other hand, GSLV obviously is a much more powerful rocket and can take up to 5 tons, that is 5000 kg of payload into the low Earth orbit and about 2500 kg of payload to the GTO, that is geosynchronous transfer orbit. Now, why GSLV is prone to failure? That is what we can try to understand first. So, overall, the issue is related to the third and the uppermost stage of GSLV, which is a cryogenic stage. So, basically, GSLV is a more powerful rocket than PSLV, and that is why in the upper stage we are using the cryogenic stage. So, problem have mainly with the cryogenic engine that powers the third and final stage of the flight. Now, what is cryogenic engine? Now, cryogenic generally is referred, a term is generally referred to talk about the science which is happening at a very low temperature. For example, in the upper stage of GSLV rocket engine, we have two different fuels. One is hydrogen, which obviously is difficult to manage in gaseous form. That is why it is stored in liquid form. Now, liquid form of hydrogen can only maintain at very low temperature, that is almost minus 250 to minus 260 degrees. Similarly, to burn with hydrogen, we have another fuel that is also in liquid stage, that is liquid oxygen. So basically, liquid oxygen and liquid hydrogen from respective tanks are fed by individual booster pumps to main turbo pump, which is rotating at around 40,000 RPM to ensure a high flow rate of propellants into the combustion chamber. And once the cryo stage carries about 28 tons of propellants in two tanks that provide a thrust of almost 20 tons. So at such a low temperature, liquid hydrogen at minus 250, while liquid oxygen somewhere at minus 90 to minus 100 are mixing and propelling the upper stage of the engine. And this is where the problem arises. Because we talk about the current technology which GSLV using, it has been brought from Russia. Somewhere in 1980s, ISRO and the Russian Space Agency has signed an agreement where Russia decided to supply a few of the cryogenic engines it was using to India. But only engines Russia was able to supply. It could not supply the technology, or it could not transfer technology behind the cryogenic engine. The reason was because US said that this kind of transfer technology is a violation of MTCR, that is Missile Technology Control Regime. And thus, India used those engines in some of its launches in the early 2000s and for later flights as well. And then from the engine that they have got from Russia, ISRO tried to reverse engineer it and try to develop its own engine. To remind you, technology of developing this engine has not been transferred by Russia to India. It has been, that is why ISRO has to devise its own understanding by reverse engineering of this. It is this reverse engineered engine that is being used in the GSLV rockets, and that has caused a few headaches to ISRO, including a lot of failures in the 15 total launches. Now, to tackle this problem, ISRO has recently shifted to develop its own technology, that is indigenous cryogenic technology. And thus, it has remained successful in a lot of instances, and it has managed to develop its own cryogenic engine as well, result of decades of research and development, we can say. It is closer to the designs of Ariane rockets that were used by ISRO till a few years back to launch its heavier satellite. This indigenously developed cryogenic engine is deployed in LVM-3, and that is how you can compare that the reverse engineered engine which is being used in GSLV is much more prone to failure as compared to the indigenous cryogenic engine which is being used in LVM-3, and all the 7 we can say launch of the LVM-3 has been successful so far. And also it is ISRO's most powerful rocket as of now. It carried the Chandrayaan-2 and Chandrayaan-3 missions among the others, and LVM-3 has had 7 flights till now without any trouble. So overall, what we can understand in conclusion, that ISRO scientists, not surprisingly, obviously since they have developed the technology by themselves, the indigenous cryogenic technology in the LVM-3, they have a much better grip on this homegrown technology. On the other hand, recent successful launch has put away the question marks on the GSLV rocket for the time being, but a more crucial test awaits it in a few weeks when it is getting ready to carry the NISAR, that is NASA ISRO Synthetic Aperture Radar Satellite. NISAR is very crucial satellite, and also it is important because it is first of its kind collaboration that we have seen in the history between ISRO and NASA, and it would be the most prestigious mission for the GSLV to carry so far. So whether it will be successful or not, that is what we'll have to wait and watch. That is all for this particular video about the ISRO's recent mission and overall issues and concerns with the GSLV engine. Thank you very much.